Okay, we're going to start talking about data representation, and what we're using frequency tables to help us organize information here. So in 1 and 2, use a frequency table of hours worked by students in a class to complete a project, and we have our frequency table right here, and it's pretty self-explanatory. If you look at it, when you're making a frequency table, you're going to order. You're going to put the numbers in order. So you got from least to greatest here. So 2 1/2, 2 3/4, 3, 3 1/4, and 3 1/2. And what they did is they went ahead and put tally marks every time they seen that it took 2 1/2 hours. And it turns out that it took 8. There's 8 students that it took 2 1/2 hours to do the project. So on question number 1, how much time was most often needed to complete the project? And all you have to do is go up here to the frequencies, either look at the tallies or the actual frequencies, how many times. You can see 8's the largest, so it took most of the students, it took, most often it took them 2 1/2 hours. So I'm going to write 2 1/2 hours, 2 1/2. Okay, how many students are in the class? So if I'm trying to figure out how many students there are in the class, that's going to be each one of these is a student. Each tally mark's a student. I can go through here and count my tally marks, or I can just add up my my numbers, my frequencies. Put together 4 and 6. We know that's 10. 8 and 2 is 10 also. Then we have 7. That equals 27. So there's 27 students in this class. 27 students. Okay, on problem number 3. Okay, when making a frequency table that uses whole numbers and fractions, how can you organize the numbers? And you do it just like we did over here, or in any frequency table. You want to order from least to greatest, or you could do from greatest to least, it doesn't matter. And I went ahead and typed that out right there for you, so it's a little bit easier. You don't have to read my chicken scratch here. Okay, question number 4. Look at the fishing links caught by Rafe's class on the previous page. How does organizing the data in frequency tables help you answer the questions asked? And just like with any frequency table, you can look back at that page, but it looks very similar to this frequency table. Okay, what it does, it organizes data so it's easier to see how often certain events happen. And that's what we wrote right here, or what I typed right there, so you can go ahead and copy that down. Let's go down here and look at some of the questions here. You can do the majority of these on your own. This is pretty easy. What I did when I typed when I converted this, some of them didn't come out quite as well. So I went ahead and typed those in for you there. And instead of writing fractions, I put it in as a decimal form. So this one right here is actually 2 1/2 cups. This is 1 3/4 cups. That's 1 3/4 cups, and 2 1/2 cups there. But I'll go ahead and kind of get you started on the table. On problem number 5, it says complete the frequency table. And the first step whenever we're making the frequency table, we want to go and put our data in there from least to greatest. And the least amount of cups it took would have been 1 3/4. So I'd write 1 3/4 right here. Okay, the next amount, the next least amount was 2 1/2 cups, or 2 5/10. And the most that it took was 3 cups. So basically all you need to do now is go through there and tell how many times it took, how many recipes took 1 3/4 cups, and then you go through there and figure out how many recipes took 2 1/2 cups, and then how many recipes took 3 cups, and you put the tally marks there, and then you write down the frequency there. And I'll go ahead and read the questions for you real quick. Question number 5. Complete the frequency table below the data. So we're going to complete that right there. Okay. How many cookie recipes are represented in the data? So you just go ahead and figure out how many different recipes there are there. It would be just like we did on the problem up there with the students. Problem number 7. Which amount of flour is most often used in the cookie recipes shown? And just whichever frequency is the most. And question number 8. How many recipes shown use more than 2 cups of flour. So we're going to figure out which ones use more than 2 cups of flour. Let's go and look at the back page. Okay, very similar. We have some data right there. It says ages at which some state laws require children to be in school. So, for instance, California, you have to be in school by the time you're age 6, and it goes through there and lists all those. Okay, question number 9. Analyze the information. Make a frequency table to organize the data shown at the right. What is the most common age when children are required to be in school for the states shown? So we need to make a frequency table, and you can see at the bottom page what a frequency table is. It has one that's not completely filled in there. We'll go and I'll kind of draw you on to get you started there. Okay. So the first one we do is the ages. It's going to be ages. The age. Okay. The next is going to be the tally marks. Tally marks. The next one is going to be frequencies. Just put F for frequency. And if you look at it, it's only showing 3 different ages. Okay, is 5, 6, and 7. That's all the. I'm sorry, it's showing 4. It's showing 8 also there, isn't it? So there's. We have to create another one down here. So my ages, I'm going to start from least. So 5, 6, 7, and 8. So those are going to be the ages. You're going to go through there and basically make the table. You're going to put tally marks for every time you see for 5. You go through and count how many of them. That's 1. You put 1 tally mark there, and go so on and count all the ones that require them to be started at age 5. Okay, question number 10. Which is more common state that requires children to be in school at age 5 or age 8? So you're going to look at the tally, or the frequency, or the tally, whichever one you want, and figure out which is more common, 5 or 8. And question number 11. How many more states require children to be in school at either age 6 or age 7 than other ages? So I'll give you a little hint here. How many more? That's kind of telling you it's going to be a subtraction problem. So giving you a little help on that. So you're going to need to go ahead and finish the frequency table out, frequency chart, to answer those questions 9 through 11. Okay, we'll go and work together on question number 12, and it's a pretty simple question. What number is shown by the tally marks? And it has these tally marks right here. And what number is shown? And that's, you got 5 here and 4 here. That's 9. So it's showing 9. Question number 13. Okay. George collects sport cards. He displays his cards in an album. There are 63 pages in the album that each hold 9 cards. Use compatible numbers to estimate the number of cards in the album if all the pages are full. Okay, so it's talking about 63 pages and 9 cards. If I look at that, I know that I'm talking about pages and cards. Chances are it's not going to be an addition or subtraction problem because the labels, I'm looking at my labels, I got different labels. And underline my question, or not, box in my question. There's not really a question, but this is what it's wanting us to do. So I'm going to go and box this in. It says use compatible numbers to estimate, another keyword right there, the number of cards in the album if all the pages are full. So if all the pages are full, we're trying to figure out how many cards there are. Cards is going to be my label for my answer. I'll go and write this down here, help me remember. So it's going to be, I'm going to figure out the number of cards. Chances are, there's more than one card per page, so my answer is going to be larger. I've got different labels, pages and cards. That's telling me it's a multiplication problem. I also see estimate right there. Estimate's telling me I need to round some. I need to do some rounding. So 63 right there is going to round to 60. 9 will round to 10. It's a multiplication problem, so that's 60 times 10. And we know that that's just as easy as our 10 facts. That would be 600. So there's about 1,600 cards in his album if it's full. Okay, and 14, 15, and 16. You're going to do these on your own. I'll kind of get you started. I'll read the questions for you and kind of help you just a little bit on this. Students in Mrs. Johnson's class are having have shoe sizes shown in the table to the right. Complete the missing parts of the table. Which is the most common shoe size? Okay, and basically what it's saying is we got some blank spaces here. Right here I see one tally mark, so that's telling me the frequency is 1. There's one person. That's a ugly 1. Okay, one person wears a shoe size 4. Okay, and on this one right here, it's missing the tally marks, but it tells me the frequency is 2, so I put 2 tally marks right there. So, and you need to go in and fill in the rest of the table and to help you answer the questions 14, 15, and 16. I'll go and read question 15 for you. Okay, which is the least common shoe size of those shown? So least common. That's going to be the one that appears the least frequency. Okay, and question number 16. 2 more students said that they wear a size 6 shoe, including the students in the data. Which is the most common shoe size? So basically we need to add maybe 2 students who were absent the day that they were collecting data, and they came in the next day and they went ahead and said, okay, well 2 more of them were size 6. So 2 more right here. And then you need to go and answer the question.